An agent is a system that perceives its environment, reasons about what to do, and acts repeatedly over time. For most of computing history that described robots and game-playing programs, a language model that can read files, execute code, and call tools is, in a meaningful sense, an agent that can do knowledge work. This video lays down the conceptual structure everything else rests on. What an agent actually is, the ladder of capability a researcher climbs, and the two threads that hold the whole climb together. Here is the road ahead. The agent and its four parts, the substrate underneath and where it fails, workflows versus agents, the capability ladder, two spines, evaluation that becomes fitness and context engineering, and why now is the moment the pieces combine. Start with the loop. At each step, the agent receives an observation from its environment, a file listing, a tool result, a user message. It forms a reasoning trace, a plan, and it emits an action, a tool call, a response, a file write. The action changes the environment, which produces the next observation, and the loop repeats until the task is complete, or the agent determines it cannot proceed. These names describe observable behavior, not cognition inside the model. Reasoning here is the intermediate text the loop produces and then acts on, whatever process generated it. Four parts named once and used everywhere. A model M, which reads the current context and chooses the next action. A set of tools T, the model can invoke. A context C, the information the model is given to read at each step. And a loop L, which runs the model, carries out its action and feeds the result back. The parts interact in a specific way. The loop assembles the context, system prompt, task description, the history of observations and actions, anything injected. The model reads all of it and selects either a tool call or a final response. The loop executes the call, appends the result as a new observation, and invokes the model again. Before building on this substrate, be honest about what it is. The model is not a database, and it is not a classical reasoner. It is a next token predictor conditioned on its context, and four properties of that substrate govern where an agent built on it will fail. It generates by statistical continuation, so it produces fluent text that may be confidently wrong, hallucination. Its knowledge is a frozen snapshot, fixed at a training cutoff, blind to anything newer or too rare to be well represented. Its working memory is the context window, bounded, non-persistent, unevenly attended. And its steerability is pattern continuation rather than comprehension of intent. It follows the form of an instruction. That last property is why long chains of steps accumulate error, and why text injected through a tool result can hijack a task. None of this argues against building. It sets the terms. Each rung of the ladder ahead is in part a discipline for managing one of these four failure modes, and the honest builder keeps all four in view. A tool is any capability the model can invoke as a discrete action: reading a file, running a shell command, calling a web API, querying a database, invoking another model. A newer kind is computer use. The model observes a screenshot and issues keyboard and mouse actions, so it can operate software that exposes no programmatic interface. Each tool is described to the model by a name, a natural language description, and a parameter schema. Hold on to one asymmetry. The toolset determines what the agent can do. The model determines what it chooses to do. A capable model with a sparse toolset is limited by its reach. A rich toolset with a weak model produces unreliable actions. Designing the toolset and selecting the model are two of the earliest decisions in any build. Now the context. The context window is the finite sequence of tokens the model reads at each invocation. Everything the agent knows at a given step must fit inside it. And unless managed explicitly, context is not persistent. What the model does not hold in its window, it does not know. A common misconception is that larger windows remove the need for context engineering. In practice, models attend unevenly. The edges of the context receive more attention than the middle, and dissonant content interferes with reasoning. Choosing what to put in the window and where stays consequential as windows grow. Not every task needs the full loop. A workflow routes the model through predetermined code paths, steps fixed in advance, control flow known, predictable, and cheaper. An agent lets the model direct its own process and tool use, flexible, open-ended, and bought with higher cost and more room for compounding error. The durable advice is plain. Reach for a workflow when the task allows it, and reserve full agency for problems that genuinely require it. And keep two ideas apart. Both designs describe the artifact that runs, neither describes how it is built. Agentic development, the practice at the center of this video sequence, is a build-time activity. A researcher directs an agent, and the software it produces is frequently a deterministic workflow or ordinary analysis code with no agent inside it at all. Developing with an agent is distinct from deploying one, and much of the aim here is to use the former to build reliable, largely non-agentic research pipelines. This video sequence builds capability in a fixed order because each rung requires the one below it. You cannot build an agent you cannot drive, cannot orchestrate what you cannot build, and cannot evolve what you cannot evaluate. Operate, drive an existing agent reliably and reproducibly. The habit worth instilling first is deceptively plain. State the objective before the agent acts. Goal clarity tracks later proficiency more closely than knowledge of any particular feature. Build. Implement the loop and the tools from scratch rather than configuring a pre-existing system, and introduce an evaluation harness, because the agent must be judged by something more reliable than intuition. Orchestrate. Compose multiple agents or steps into a reliable workflow with failure handling, logging, and the proposer-critic pattern, one agent generating candidates while a second verifies or scores them. An orchestration that can run unattended for hours is the prerequisite for what follows. A search cannot be trusted if it fails silently. Evolve, orchestration, plus a mutation operator and a fitness function. A system that generates candidates, evaluates them, and selects the best is an evolutionary algorithm, whether or not it is called one. And randomness is native to this substrate. Sampling from the model's output distribution means two runs of the same prompt can take different paths. One pattern runs up the whole ladder. The mechanics keep getting easier. Asking an agent how to commit your work once a real hurdle is now trivial. The judgment underneath does not get easier. Why version control matters, and whether a build serves discovery stays yours to hold. And the escalation has a summit that no tooling reaches, which questions are worth pursuing and what the results imply. The promise of everything that follows is to clear the mechanical work away from that judgment, not to make it for you. Two threads connect every rung of the ladder. Call them spines, because everything ahead hangs from them. The first is evaluation. You cannot trust an agent you cannot score, and you cannot evolve an artifact you cannot score automatically. The model generates by plausible continuation, so its output is fluent whether or not it is correct. Trust must come from an external score, never from the confidence of the text itself. Early on, you build an evaluation harness and use it to compare methods. Later, when the goal becomes an agentic evolutionary framework, the same harness is used to drive search. Nothing about the harness changes, its role changes. Evaluation becomes fitness, and this transition is the conceptual hinge of the whole progression. Not every harness can make that jump. To serve as a fitness function, it must be automatic, running without human judgment. Leakage resistant, so it cannot be gamed by artifacts that overfit the split it scores. Cheap and stable enough to be queried many times over, and distinct from any final test held back for a one-shot audit. How the score is computed sits on a spectrum of evaluability. At one end, verifiable problems, where an unambiguous oracle settles quality, a program passes its tests, a fitted model has a measurable error. At the other, judgment problems, where no formula exists and a capable model scores the artifact against a rubric. Which end a task falls on is a property of the problem, not a preference. One caveat travels with the promotion. A fixed evaluation may lose discriminating power as capability rises. In such cases, you may treat the fitness function as an evolving artifact to refresh, not a fixed target. And because the discernment to catch a plausible but false claim does not grow on its own with exposure, evaluation is practiced deliberately and revisited at every rung. The second spine, a language model, is a function of its context. What it proposes, generates, or decides depends entirely on what it reads. Deliberately constructing what goes into the window is the primary lever an agent builder has. That lever has matured through 3 levels: prompting, which question to ask and how to phrase it. Context engineering, which arrived with large windows, how to fill a huge window well, where to position each element, when caching pays off, and when to clear rather than accumulate. And agentic context engineering, the current shift. The context is increasingly assembled not by you, but by an agent working on your own machine. The questions move accordingly. Keep a file hierarchy the agent can navigate. Make the corpus searchable with ordinary tools. Choose formats that are cheap in tokens and time. Curate the instruction files the agent draws on. The lever has moved from wording a prompt to shaping the environment an agent builds its own context from. Followed to its end, this spine meets the first one. An evolutionary search works best when the mutation step reads the lineage of what has been tried, the domain priors, and the best candidates so far. Evolution is context engineering in a loop. Agentic systems have existed for decades: rule-based expert systems, reinforcement learning agents, robotic planners. What makes this moment distinct is the general-purpose tool-using language model and three capabilities combined to make the shift significant. Instruction following. The builder does not program the model's behavior in code, they describe it. A geologist who wants seismic records downloaded, filtered by magnitude, and summarized in a figure writes that goal in plain English, not in a programming language. Tool use. The model can act in the world, read files, run code, search the web, and fold the results into its next step. In principle, the same actions a researcher performs at a computer. And structured output. Models can be constrained to produce a specified schema, so the output of one agent becomes the structured input of the next. This is the glue of orchestration. Together, they make a language model a plausible substrate for a research assistant that can be directed, composed, and evaluated programmatically. This video sequence is about doing that well, reliably, reproducibly, and honestly. One fair question hangs over everything. If the platform keeps improving, does your engineering get absorbed? Part of it does, and should. Generic prompt crafting and transport-level tuning are being standardized into the platform. What does not compress away is the part specific to your problem, the evaluation that measures what you mean by better, the corpus that encodes your field's judgment, and the loop that composes them into something trustworthy. The durable skill is building the parts a general system cannot know to build for you. Here is the paradigm on one card. An agent is a model, tools, context, and a loop. The latter climbs operate, build, orchestrate, evolve, each rung requiring the last. Spine 1, evaluation becomes fitness. Spine 2, context engineering, maturing into shaping the agent's environment. And the moment, models that can be directed, composed, and evaluated. The key idea to carry away: an agent is a model with tools, context, and a loop, and mastering it means climbing 4 rungs along 2 spines: honest evaluation and engineered context. Everything that follows in this video sequence is one of these ideas made concrete.